Okay, welcome back. So let's today's let's just solve this problem now. Problem one. Find the angle between the two vectors. Vector A 2i 2 unit vector I plus 3 unit vector j plus unit vector k, and we have b vector b given to us minus 4 unit vector I plus 2 unit vector j minus k unit vector. In this case, when you have a single unit vector here, this represents the unit, the coefficient of this unit vector be 1. Likewise, this one 1, 2. Okay. Now, first thing for more, what will just come to your mind is your scalar product. Scalar product, and now, okay, solution. And the scalar product is a vector A dot vector B, which is equals to the magnitude of vector A. And don't forget that these two vertical bars represent magnitude. And the product, scalar product of vector A and B equal to the product of unit vector. The product of the magnitude of vector A and magnitude of vector B cos theta. And don't forget from formula we did earlier, cos theta given to us as arc cos so we have this. Now that will give us ax bs plus ay by plus az bz all over the product of magnitude of vector A and magnitude of vector B. So that's what's going to give us. And let us try this. But if you want to do this, we need to express vector A dot vector B as ax bs plus ay by plus az bz, so that we can input them into this formula. At the same time, we also have to do what the magnitude of vector A and the magnitude of vector B. You have to just work this ones. Now, okay, this side, this angle now, the ax will be given to us from this. Ax will be 2, ay will be 3, and az will be 1. I told you there's a unit vector here. The coefficient there is coefficient here. Coefficient of this unit vector k is 1. Oh, sorry, B. Sorry. Okay, S component of vector B Let's give it to those as minus 4. We have minus 4 by 2, and bz be what, minus 1 units. The coefficient of this unit vector is minus 1. So let's move ahead. Let's continue. So definitely now for us to have this one, let's input the value of the above letters, components. So definitely we have this x x component of vector ax multiplied by bs, that will give us minus 8. I'll be 2 multiplied by minus 4 plus 3 multiplied by 2. So we are following this, and az, which is 1, multiplied by bz is minus 1. So we close the big bracket, and that will give us what? We have minus 8 plus 6 minus 1. What would that give us? That would give us minus 3. This one. The product of this one is minus 8. The product of this one is 6. The product of this one is minus 1. So we have minus 8 plus 6. That will give us minus 2. And minus 1. That will give us minus 8. Therefore, we have this. Okay, let's continue. Let's go to magnitude of A. Let's work magnitude of A and magnitude of vector A. So we have a square root of okay, let me recap the formula. AS square plus AY square plus AZ square. I have to get to the magnitude of vector A. So let's move it. You have the square root. Oh, sorry. Don't mind that square root. What's happening? Guys, put a smile on your face. Now, so A square and A is AS is 2. I'll be 2 square plus AY is 3. Now be 3 square plus AZ is 1. That is 1 square. Now what would that give us? Just 4 plus 9. 2 square is 4. 3 square is 9 plus 1. That will give us 13 and 14. As 4 plus 9 is 13. 13 plus 1, that's 14. You will now have square root of 14 here. So therefore magnitude of vector A gives square root of 14. Mind you, magnitude of vectors are okay. Let's move ahead. No unit. Let's move to the next one. Magnitude of vector B. Vector B. Okay. We have this. We have BS square plus by square plus bz square. Now we give us bs square. Let's go back to, let's check these very well. We have BS is minus 4. As minus 4 square plus, I see the way I wrote I put this on the, okay, the next one is by square, and by is 2. It's 2 square plus bz is minus 1. It's minus 1 square. So and that would give us, so we have and as first scale, that will give us 16. Minus 2 scale will give us 4. 16 plus 4, that 20. And minus 1 scale, that is 1. 20 plus 1, we have square root of 21. So therefore, magnitude of vector B give us square root of 21. So let's check the formula, the formula above. So it shows that we provided all this. And then we have recall. Theta is equals to the angle between the two vectors is equals to cos ax bx plus ay by plus az bz all over the magnitude of vector A multiplied vector B. So therefore, let's just input those expressions that we've gotten earlier. Now, of course, and now what do we have again for? What do we get? What do we obtain for the x ax bx plus ay by plus az bz? I think we got 3 for that. We got minus 3 for that. Let's put it in this formula, minus 3 all over a magnitude of vector A, that is a square root of 14 what about the magnitude of vector B? A square root of 21. Still remember your sword. Okay, therefore we have arc hertz minus 3 all over square root of 14 multiply by 21, and that will give us that will give us minus 0.175. Therefore, theta will be given to us at 100 degree. So that's just one. Can I quickly move to vector products? Vector products. Now talking about the product of vectors. So two vectors. We have a scalar product. We also have the vector product. Have the vector product. So I want us to just move to vector product. Now, what case can we have a vector product when you're talking about when you have, the vector quantities, when you have example like torque, like example of angular momentum, vector r cross vector linear momentum, that is vector p. So we have a scale and we have a vector product. Okay, let's go ahead. Let's move on. Okay.